What role do thermal interface materials play in electronics cooling? Imagine your computer or smartphone working perfectly without overheating. How do they stay cool inside? The answer lies in tiny but mighty components called thermal interface materials. These materials are essential for moving heat away from electronic parts. When electronic devices operate, they generate heat that needs to be transferred out quickly. Without proper heat transfer, devices can overheat, slow down, or even get damaged. Thermal interface materials fill microscopic gaps and imperfections between two surfaces, like a chip and a heat sink. Even if surfaces look smooth, tiny air pockets exist because of surface roughness. Air is a poor conductor of heat, so these gaps act like barriers that slow down heat flow. Thermal interface materials are designed to replace these air gaps with substances that conduct heat much better. This makes the heat transfer process more efficient. Most thermal interface materials are made from different substances. Some are pastes or greases that spread easily and fill small voids. Others are made from carbon nanomaterials that have very high thermal conductivity. Metal-based materials, such as those containing copper or silver, are also used because they conduct heat very well. Each type has its own advantages depending on the application. For example, thermal greases are flexible and easy to apply, while metal-based TIMs are more rigid but offer superior heat conduction. In practical terms, thermal interface materials are used in many electronic devices. They help cool power electronics in electric vehicles, data centers, and industrial machines. They are also found in everyday gadgets like laptops, LED lights, and automotive electronics. By improving heat transfer, TIMs help keep devices running at safe temperatures. This prevents overheating and extends the life of the electronics. From a thermodynamics point of view, thermal interface materials improve conduction. They create a better thermal pathway by ensuring direct contact between surfaces. This reduces thermal resistance, which is the measure of how much a material resists heat flow. When resistance is low, heat moves faster from the hot component to the cooler heat sink. This process is vital because as electronic devices become more powerful, they generate more heat that needs to be moved away efficiently. In summary, thermal interface materials are like the connectors that make heat transfer smoother and faster. They fill tiny gaps, improve conduction, and help keep electronic devices cool. Without them, heat would struggle to escape, and devices could overheat quickly. Their role is simple but vital in keeping electronics safe, reliable, and long-lasting.